linear functions, generally known as straight line graphs. Now, we have a standard equation, or should we say a standard equation for straight line graphs. Normally, should we say in the old syllabus, you would find it written as y is equals to mx plus c. In the modern textbook, particularly the Mind Action series, you find it written as y is equals to ax plus q. I find it a little bit ambiguous in this fashion, because a represents quite a number of things in the functions to come in future. For instance, your quadratic functions have got ax squared plus q, and then another one comes and says ax squared plus bx plus c, and those a's there represent something totally different from what is represented in the straight line graph. So the distinction made by y equals to mx plus c is rather more pertinent in the understanding of your straight line graphs, because your m basically represents the incline, or should I say the gradient of the graph, when then your c value actually represents your y-intercept. So in this case, having to use ax plus q, obviously your q being the y-intercept and a being the gradient, might actually start confusing some students as you go into other functions, saying your ax squared plus q, ax squared plus bx plus c, thinking that a is still the gradient as depicted by the straight line equation. So yeah, I'm just making a note for you so that you notice why I'm commonly going to be using y is equals to mx plus c. It's more or less the same thing. It's just a much easier and quick to identify method that I prefer to use in dealing with such equations, or should I say in such functions. So having said that, we're given three linear graphs. One is y equals to x, one is y equals to 3x, and y is equals to 4x. And we are expected to sketch these three graphs on the same set of axes. For you to do this, obviously you're going to have to create a table where you're going to choose values for your x between, say, for instance, -2, -1, 0, 1, and 2. So you choose those values. With those values, you're going to substitute them into the above equations in order to find your y values. And your y values, remember, the first equation is y is equals to x, so we're going to substitute the value of x and find y. The same we're going to do for y is equals to 3x. You substitute and find y, and then for y is equals to 4x, and find the value of y. And then after that, we're going to sketch the graph right there. So when you substitute for y is equals to x, honestly it is a straight given answer. Whatever the value of x is, y is going to be that value. That's what it means. So that's going to be -2, -1, 0, 1, and 2. That's complete. for y is equals to x. Now for y is equals to 3x, now that changes the whole dynamic. So let's see what happens. So y equals to 3x means I must multiply -2 by 3, that's going to be -6. -1 by 3, that's going to be -3. That's going to be a 0. That's going to be again a 3. And then that's going to be a +6. And then we do the same for the 4 by 2, that's going to be -8. And then by -1, that's going to be a -4. By 0, it's a 0. By 1, it's a 4. And by 2, it's an 8. Now, as you can notice, I told you the standard graph, linear graph, it's actually y is equals to mx plus c, or should I say y is equals to ax plus q. Now for the value of m, which is your gradient, depending on whether it's positive or negative, it will tell you where the graph is going to actually incline to. If it's positive, it's going to, a positive m is going to incline to the right, and then a negative gradient will incline to the left. And whatever the value of q is will either shift the graph up or down depending on whether it's negative or positive. So in this case we have a q or a c that is 0. So that means where the graph touches the y-axis is at origin, because it touches q at 0. That is, your y-intercept is at 0. That is the point of origin. So now we're going to plot the graph, or in fact the graphs. So I'm going to go that way for my y-axis, and then that way for my x-axis. That are going to be my negative values. Right, I'm going to have -1, -2, -3, -4, -5, -6, -7, -8. Mine is not down to scale, but you have to do it to scale, because you know you're a student and you have to make your work neat. And then I'm going to go again above. It's gonna be 1, 2, 3, 4, 5, 6, 7, and 8. And then I'm going to have -1, -2, -3 on my x. I'm just going to end there, and there's going to be 1, 2, and 3 on the x for the positive values. And then now what we're going to do is we're going to coordinate the points. Remember the one for y equals to x, every point is where, for instance, okay, it can be that way. It's minus to minus, positive to positive, positive to positive, -2 to -2, and then we join those points passing through origin, and that is your y equals to x graph. Done with that one. We go to the next one. It's going to be -6 goes with -2, -6 for y, -2, and then -1 goes with -3, -1 goes with -3, and then where does it pass? It passes at origin. Good. And then after that it goes to 3 corresponding with 1, 1 corresponding with 3, and then 2 corresponding with 6, and then we join all those lines. There you go. And that would be the graph of y is equals to 3x. Okay, and then last but not least, y equals to 4x. That's going to be where -2 corresponds with -8, and your -1 corresponds with -4, and passes through origin, goes to 1 corresponding with 4, and then it goes to 2 corresponding with 8, and then we join all those points all the way up there, right? And then that's going to be an arrow. That's your y is equals to 4x. You do notice now what happens as your coefficient of x, which actually is represented by m, the gradient, increases, the incline of the graph further increases as well, which means if we were to draw a horizontal line against each of these graphs, what we would call the angle of inclination, theta, which obviously would be somewhere there for this one, and for this one, if that was the line, it would be somewhere there, and this one would somewhere there. So as you notice now, from the smaller one, y equals to x, the incline is rather more